All right, so what I'd like to do today is talk about functions. All right, so I've done a little bit of talking about functions in class, so what I just want to do now is talk about whether this is a function or not. Okay, now by definition, a function is a relation for which for each input there is only one output. So you put a number into your little black box, your little algebra math machine, and only one number comes out, and it's always the same number. So the only way really that you can say that something is not a function is if you put a number in and you get a different number out. So you get two different answers or two different solutions. So let's go ahead and look at some examples. We're going to look at some tables. We'll look at just a group of points. We'll look at a graph. And so we'll kind of talk about a couple of different situations. All right. So first, here we have a table. So the question is this a function? So in order to tell whether it's a function, we need to look at the inputs. The x is always the inputs. So 1 goes in, 5 goes out. 5 goes in, 7 comes out. Now here I have a y. This is often also written as f of x. Okay, so the x is the number going in, f of x is the output of your function. Now, the only time it won't be a function is if you have the same input that has a different output. Now this one, if I put 5 in, I'm getting 7 out. So if I put 5 in again, I still get the same out, same 7 out, which means that yes, this is likely a function. There's nothing here to say that it's not. All right, so let's go on to the next one. Here's another set. Okay, now this one doesn't even have the same input more than once. And so again, there's nothing here to say that this is not a function, because each time I put a number in, I get a number out. Put a number in, get a number out. There's no input here that has two different output values. Again, this y can be f of x. So again, we're going to say this one is a function. Okay, how about the next one? So this time we have a table, a graph. Now again, x is the input, and y, which is f of x, is going to be our output. All right, so we're going to look at each of our inputs here and see if there's any that give us two outputs. Well, if I put 5 in for x, I only get one y value. If I put 4 in for x, I get one y value. If I put 3 in for x, still there's one y value. Okay, so it's not until right here. Can you see this point at -2? Can you see right there that if I put -2, if -2 is the x value, I put that into my little function machine, I got 4 out once, and I got -2 out a separate time. So I'm getting two different y values, two different outputs, two different f of x's. And because of that, this cannot be a function. It is not a function because for one of the inputs, there is more than one output. All right, so let's look at another example. Here we've got a list of points. Now, points are always listed as x, comma, y. And again, that y can be f of x. Okay, so I put 2 in, I get 5 out. I put 5 in, I got 7 out. Now these aren't really following any specific pattern. Now that's not a problem. They don't have to follow a specific pattern that's very obvious. You can actually get numbers like this that follow a kind of wonky pattern, some type of other relationship. So just because you don't see a pattern doesn't mean that there isn't one. Okay? However, the problem here is that I put 2 in, and I have two different values. I've got f of x being 5 here, and I've got it being 10 there, which means for one input, I have two different outputs. That means that this is not a function. So by this time, hopefully you've kind of put things together, and if you want to make kind of a simple rule for yourself, you look at the x values, and then you look at the y values matched up with those, and if any x value is repeated and has a different output, then it's not a function. It's okay for x to repeat as long as the number is the same output, the same y or the same f of x. It is not okay for the same input to give you a different output, like in this case. Okay, so I'm going to give you one more set. This time, go ahead and pause it because I'm going to give you the answers in just 1 second. Okay, so hopefully you paused this, and so let's see if we can figure out if these are functions or not. Okay, well here there aren't even any repeated x values, so we're going to say yes, that's a function, because there's no inputs that have outputs that don't correspond. Okay, look at this one. I've got -2 that repeats, but both times it gives me the same output. That means this is a function. Okay, let's look at this one. Can you see the 3's there? The 3's repeat. Do they give you the same output both times? Remember, y is the same thing as f of x. Do they give you the same thing? No, they don't, which means this is not a function. All right, how about this one? Now, some students get confused. They say, well, there's 2 4's and it has different values. That doesn't matter. We're looking at the x values. The x values never repeat, and so they don't give us conflicting outputs. And so this is okay. Yes, that is a function. How about this one? Okay, well, I've got -2 that repeats here. That gives me the same value both times, so that one's okay. But this one, the 4, gives me a 3 here and gives me a 2 there. That means this is not a function because for the same x value, I get different outputs, different y values. All right, last one, -2, -1, 3, 0, 2. Okay, no pattern, but that's okay. All of these inputs are individual values. None of them repeat with a different output. And so, yes, this is a function. All right, well, hopefully those examples were enough to kind of help you out a little bit and help you understand what makes it a function and what makes it not. All right, so until next time, ciao.